My name is Christopher Andren. I work with Chemir Analytical Services, which is a division of Evans Analytical Group. I appreciate all your time today. A quick 15-minute case study presentation. And if you're on the phone right now, chances are you attended our UL Prospector webinar last month. Actually, it was the end of April, dealing with many case studies involving plastics and polymers. And as promised back in April, we're going to give some more detail on each of those case studies. And today's specific topic will be a plastic failure investigation. And so the presentations we gave through the UL Prospector back in April were all topics that we presented at NPE, National Plastics Exposition 2015 in Orlando in March. So these are the different case studies that we presented in booth at NPE 2015 and gave abstracts of these case studies at the UL Prospector seminar in April. And today's discussion is going to be discussing finished product failure investigation. And let me quickly ask anyone that's joining, please put your phone on mute because I can hear you and probably others can hear you as well. So I'm the only one you need to listen to right now. So again, we're going to discuss a case study, a real investigation we provided here at Chemir dealing with a product failure. And again, a snippet, if you were on the UL Prospector seminar back in April, again, Chemir Analytical Services is who I work with. Chemir is a division of EAG, which is a large group of analytical labs, lots of deep scientific and analytical expertise across the U.S. and labs across the world. 3 quick slides, analytical instrumentation, and feel free to visit our Chemir and EAG website, and you can look at all these different tools that we have at our disposal. But page 1 of these analytical tools, page 2, even more analytical tools, page 3, even more, and there's even more that we do. So again, just a real quick snippet of all the analytical instrumentation that we have at Chemir and EAG that can be used to investigate failures, product characterization, a wide variety of analytical work. Mainly the topics at NPE, we're dealing with polymers and polymer additive expertise that we have within EAG. So many different polymers that we deal with through clients that come to us with polyolefins, engineered resins, adhesives, specialty materials, everything you see there. So again, polymer expertise is just one of the skill sets that we offer at EAG. Today's case study is more details on the abstract that I provided last month on a failure investigation. So again, here's some analytical detail on how we address this product failure and how we established a root cause. And I'll ask one more time for new people joining, please put your own phones on mute so we all don't hear what's going on your end, and you can just listen to me quietly. Now, any failure investigation, I mean, it's certainly a quality issue. And a case that came to us several years ago, the problem was a fluorescent lighting fixture. It's a manufacture of different components that go into a fluorescent lighting fixture. Look above your head, and I'm sure you've got some fluorescent lights up there. And the issue that their client was having, our clients were having issues where bulbs were falling from the fixtures, and that's certainly something you don't want. And the investigation was to understand why these lighting fixtures were failing, why the tension supporting and holding the bulbs was coming loose and causing bulbs to literally fall from the fixtures. The analytical approach, and again, you're going to listen to the distilled version of just what we did to actually solve the problem. A lot more time, a lot more thought, much more of a very iterative approach goes into any type of investigation like this. So you're going to see everything that worked, all the analytical techniques that provided an answer, but keep in mind many analytical techniques may not have shown anything that led to the root cause. So again, you're seeing the easy final solution, and it may seem very intuitive seeing what we did, but a lot of thought, several weeks, 3 or 4 weeks of analytical effort and discussion goes into these types of investigations. The analytical approach for this failure, certainly inspecting the failures with things like optical microscopy, characterizing the base polymer that was used in different components of the lighting fixture, just confirming that the polymer is what it's supposed to be, thermal analysis, molecular weight profiling, looking for contaminants with different analytical techniques. So again, a combination of different analyses applied towards investigating the material. And often the approach for a failure investigation involves a comparative analysis of a control sample and a failed sample. So looking at a good material, one that has all the properties that it should, looking at the failed material and looking for chemical differences against the good sample, the control, and trying to line up those chemical differences with the failure and the root cause. So here was the issue. Now these are what are known as tombstones. So in a fluorescent light, and if you've ever installed a fluorescent light, these look familiar to you, and these are referred to as tombstones. Now we never knew that until we started working with this client, but this is the term used for those ends that support the bulb, have the electricity running through. But again, these are the tombstones of the fluorescent light fixture. These are what were failing. And what was failing is cracking, or the failure that was noted was cracking in these tombstones. And when the cracking occurred, it was no longer able to hold the tension and support the bulbs in the fixtures, and so the bulbs were falling down. So this is what was being noted, is this type of cracking in the tombstone. And curiously, this was only an issue with one specific client. It was a very big client of our client. A very big client had this issue, but it was unique to just one client, as I said. So that kind of made it very interesting as why this failure was happening with one client, but not with others. Some analytical tools that were used, and for those out there who know analytical chemistry, this is infrared spectroscopy, providing a chemical fingerprint of just the base resin, looking at a good material now, the base resin. And so getting a chemical fingerprint of what the polymer should be, and the chemical fingerprint for the samples we analyzed, the control samples, show that it's a type of polycarbonate, as it should be. A different analytical tool, just to confirm the polymer and some of the polymer structure, we use a technique, NMR, nuclear magnetic resonance spectroscopy. Provides more structure of organic molecules, and the NMR analysis just confirmed that we have a basic type of polycarbonate resin, as it should be. So two different analytical tools just showing that the resin is made of what it should be. It's, someone wasn't substituting a polyethylene or a PVC when it should have been a polycarbonate. Now, knowing that it's a polycarbonate, that immediately gets us thinking as far as possible failure routes. Polycarbonate, very common thermoplastic resin, but there are known failure mechanisms of PCs, of polycarbonates. Now, part of a failure could be mechanical or design issue, and that's really not what we're investigating at Chemir. I mean, we're looking for chemical reasons for a failure. But again, there could be a chemical or design issue associated with the failure. More often, it's more chemistry, degradation, like something like environmental stress cracking, just environmental exposure to different chemicals that result in degradation of the polymer. So for those polymer folks out there on the phone, you're very familiar with polymer degradation that could be caused from temperature, UV exposure, chemical exposure, things like that. So again, now that we knew that it was a polycarbonate, or we confirmed it, it kind of starts focusing our attention on just what could cause the polymer degradation, if indeed that's what's occurring. Now, analyzing a failed material, so one of those tombstones that actually cracked and failed, we looked at the polycarbonate, but now the top spectrum is the control sample of the polycarbonate. The bottom spectrum here on this slide is the polymer resin from a failed sample. And you see some chemical differences in that failed sample. And this is ideally, and this is what we're looking for. And so we see some peaks in the IR spectrum that are consistent with a certain type of chemical functionality, and a certain chemical functionality that should not be present with polycarbonate. So this is starting to give us some clues on something that's chemically attacking the polycarbonate. Now, doing a more focused analysis and looking under optical microscopy, we actually saw some residues, some small amounts of some white residues that were present in the cracked regions of these failed tombstones. We isolated a very small amount of this material, provided, did another chemical fingerprint with IR, and had a very good match, at least a partial match, for a specific chemical, dicyclohexylamine. And so, again, the IR showed some degradation of the polymer or some chemical change of the polymer. A small amount of some foreign residue that we saw under microscopy that we analyzed showed a specific chemical that shouldn't be part of a polycarbonate. Dicyclohexylamine is not the additive or stabilizer or process aid. It's definitely a foreign chemical. And here's the structure for DCH. Applying a different analytical technique, actually extracting, this is some data from gas chromatography analysis, where we extracted, using organic solvent, extracted some of the failed regions of these tombstones. And we would have done the same chemical extraction of control samples, of good materials, and compared them. And essentially what we're showing here is an extraction of the failed tombstone analyzed with GC mass spec, gas chromatography, is showing evidence for dicyclohexylamine. So again, we have two different analytical techniques that are providing the same results. So in this case, we're seeing dicyclohexylamine using IR and using a gas chromatography technique. So dicyclohexylamine is present. Here's a mass spectrum of dicyclohexylamine, just kind of confirmation from the GC analysis. And again, GC mass spec is just providing fragmentation of the organic molecule, which is another form of chemical fingerprint. Let me back up a step. So again, distilling things down, a lot of different different analyses are pointing towards the fact that there's a chemical attack that's occurring with the polycarbonate. We see a change of the polymer chemistry. We saw a molecular weight change with a degraded material. Now, I didn't have that present that data here today. Again, we saw dicyclohexylamine as actually a physical solid material on the polycarbonate. And so there is a chemical reaction, aminolysis, which can attack certain ester bonds with polycarbonates. So our theory was that there was some chemical attack. DCH was attacking the polycarbonate, but our customer really wanted to confirm, is this truly what's happening? Or is it maybe just a coincidence that we see some dicyclohexylamine, we see aminolysis of the polycarbonate? Maybe it's a coincidence that the DCH is just present on the cracked polycarbonate. So what we recommended or suggested, and they approved, is we did a controlled exposure where we exposed these polycarbonates to dicyclohexylamine, a forced degradation study. And you look at these different tombstones going from left to right, showing a control sample that was just in a sealed container with no chemical, with no exposure to dicyclohexylamine. And again, marching from left to right, you see a dramatic impact that DCH has on polycarbonate when it's exposed. So this was really proof positive that exposure to the polycarbonate with DCH is causing this issue. But now the question is, where is DCH coming from? And if you remember, I mentioned earlier, this failure was only at a single client of our client, a single large facility. Where this failure was occurring. So what is DCH? Where did it come from? Well, the outcome, and again, the conclusion from all this, and part of the answer is here, is again, the dicyclohexylamine was responsible for the degradation of the polycarbonate. We seem to prove that conclusively. And through little literature research, talking with the client on their client, what did the client of theirs do? What was their facility? What were they manufacturing? Where these issues were occurring was a metal working facility. A lot of metal working, a lot of metal cutting, a lot of temperature, a lot of heat, a lot of cutting fluids used for these metals. And we found that DCH is a corrosion inhibitor in cutting fluids. And this DCH was used at this specific facility. And again, this kind of information comes from discussions with the client. So if you're one of our clients, this is some of the dialogue we had back and forth, explaining some of our analytical results, trying to get a cause and effect, and through discussions with our client and our client talking to their client that had these issues, finding DCH is used in cutting fluids, used at the specific facility. This facility ran 24/7. If you ever cut metal, you know it's a hot process, and the semi-volatile DCH was volatilizing from these cutting fluids and condensing different places, but including on the polycarbonate, and causing this degradation. So our deliverable to the client is DCH is the issue. Discussions with you identify DCH as being used at this facility where these failures are occurring, completely takes the liability off our client, the manufacturer of these tombstones. And that's pretty much the driver behind this analysis. Who is liable for all these failures? And it was not liability of our client, the manufacturer of these fluorescent fixtures. So again, that was the money driver behind all this. And what this ended up, our result, another end result is that the client, this metalworking facility, was able to identify different cutting fluid, different corrosion inhibitors, things that didn't impact the polycarbonate. So it was a relatively easy fix for their client, and again, just a different end result from this root cause analysis. And this case was solved. It gets the rubber stamp there that this was solved. And again, in 15 minutes, you saw probably 4 weeks worth of analytical effort kind of distilled down in a very, maybe intuitive. You're thinking back, well, of course that's the reason why this occurred. But imagine getting a degraded tombstone on your desk, you're looking at it, and it's up to you to figure out how this happened. Difficult thing to do. That's why you come to a lab like Chemir. This is the kind of work that we provide. And so any questions that you have, again, I promise I'd hold this to 15 minutes. We're at 16 minutes right now. Any questions that you may have, you can go to our website. This brief webinar is going to be on our website. Here's my contact information. Again, Christopher Andren, one of our senior technical specialists, essentially providing project design work for the clients that we work with. I'm an analytical and materials scientist, but that's me. That's our phone number. That's my email address. So any questions you have, feel free to send me an email, give us a call, visit our website if you want to listen to this webinar again, this GoToMeeting. And keep in mind, we're going to have at least 2 additional 15-minute webinars like this, one on Thursday, one I believe next Tuesday, that we'll email the people that attended the UL Prospector webinar, 2 different case studies that we're going to provide the details, just like I did here. Some details on a plastic failure investigation, a packaging failure investigation, and a 4th one, which I don't remember right now, but very challenging, very interesting work. So we hope you attend those 2 meetings on Thursday and next Tuesday. So again, please contact me if you have any questions, and thank you very much for your time. Goodbye.